Thank you for joining this lesson. We're going to discuss physics paper 2, number 17, part A. State the properties of X-rays which makes it suitable to detect cracks in bones. So the property of X-rays, amongst the many, but the one which strictly makes it possible for X-rays to detect cracks in bones is the fact that X-rays possess energy. X-rays possess energy. Now it should be known that it is this energy which enables X-rays to penetrate matter. And if they have now the ability to penetrate matter, then when there is a crack in a bone, it can be detected. So this enables X-rays. This enables them to penetrate matter. So there are two properties anyway, but in one, it is the possession of energy which enables the X-rays to penetrate matter. Figure below shows the features of an X-ray tube. So this is an X-ray tube where X-rays are produced. Now in the X-ray tube, we can see some parts labeled with unknowns, others indicated like oil in and oil out. Then when we proceed to the questions now, like in part 1, we are told to name the parts labeled A and B. So when you see the arrow which labels or which is labeled A, that arrow is pointing at what we call the cooling fins. The cooling fins. These cooling fins are made of copper. Sometimes we call them the cooling copper fins. We can look at B. B is the anode. It's also made of copper. So in some cases, we can call it the copper anode. The copper anode. Part 2. State and explain which material is suitable for part C. Part C, which is on B. This is called the target. The target is usually placed on the anode. So the target is made of a material called tungsten. Tungsten is the material which makes the target, and we are stating and explaining the material which is suitable. Tungsten, due to its high melting point, so as to withstand the high temperatures at the anode. So at the anode, we have energy conversion, whereby energy in the electrons, these are electrons, energy in the electrons is converted to X-rays, but a bigger percentage of that energy in the electrons becomes heat energy. So the heat energy now has to be dissipated away, or rather absorbed away, and the heat energy is absorbed away by having the anode made of copper. We also have oil in and out. We have copper fins. They all enable in cooling due to that heat. But again, now the material here, which is the exact target for the electrons, should be made of a material with very high melting point so that it doesn't melt easily because the heat is very great. Say the reason why the machine should be surrounded by D. D is a lead shield. This is a lead shielding. A lead shield. Why is it surrounded by D? D is lead. Lead has high density. So this prevents the person operating the X-ray machine from stray X-rays. It's good I mentioned this, that the X-rays are directed through the window. This one is called the window through which the X-rays are coming out. X-rays are produced, then they are channeled to their point of usage directly. They are not stored anywhere due to their high penetration ability. Now, the person operating the X-ray tube should be protected from stray X-rays. Those are X-rays which might not be perfectly focused through the window. Therefore, such X-rays now, which might enter the skin of the person operating the machine, and remember they have some dangers when they land on the screen, they can even cause cancer. Now, the X-rays, so that they may not go to the skin of the person operating them, operating the machine. Now, it is only a lead shielding which can prevent X-rays from penetrating to the outside. Or rather, the lead shield just absorbs any stray X-rays. Those are the X-rays which do not go through the window. State one way in which cooling is achieved in this X-ray machine. This to mean that cooling is achieved through several ways, but the examiner is requesting for one. Let me mention all of them. One, cooling is achieved through part B, which is the anode made of copper. It ensures that because copper is a good conductor of heat, immediately the heat is converted, it is efficiently dissipated away by the copper anode. Two, there is oil in and oil out. The circulation of oil also ensures that heat is transmitted away. Again, there is the cooling copper fins, that is part A. The cooling copper fins, they also help in cooling the anode. Finally, we have a part C. The figure below shows the trace on the screen of an AC signal connected to the Y plates of CRO with the time base on. So this is the display on the screen of the AC signal. Given that the time control is 5 milliseconds per division, and that the Y gain is 100 volts per division, determine part 1, the frequency of the AC signal. For us to get frequency, we have to start with what we call periodic time. According to the time-based setting, per division, there is 5 milliseconds. Therefore, ours is to see if in one division or 1 centimeter, there is 5 milliseconds. What about in a complete oscillation, a complete cycle? That is, a complete cycle is moving from this point all the way to this point. So all that flow is what we are calling one oscillation, or between two crests, two successive crests, like from this point to this point. So between two successive crests, I'm seeing 1, 2, 3, 4, 4 divisions, or in a complete cycle, 1, 2, 3, 4. Yeah. So there are 4 divisions in a complete cycle. Therefore, we say in one division, it's 5 milliseconds. What about in a complete cycle, whereby there are 4 divisions? So we're going to have 5 by 4 divided by 1, and this gives us 20 milliseconds. So this is periodic time, which can be converted. Remember, periodic time is the time taken to cover a complete oscillation. So this time can be converted into seconds, the SI units, by dividing by 1,000. To divide by 1,000 can also mean to multiply by 10 to the power of -3. We know very well that from waves, the relationship between frequency and period time is that one is the reciprocal of the other. So now when we take the reciprocal, we're going now to get the answer. Let me now check on the answer. When we take 20 times 10 power negative 3. Then now we take the reciprocal. This gives us exactly 50. So the answer is going to be 50 hertz. We got number 2, which talks about the peak voltage. So for us to get the peak voltage, that is the highest voltage registered, remember this signal can be used as a voltmeter, so we can measure the highest voltage registered. According to the Y gain setting, we have 100 volts per division, and the highest number of divisions in the vertical axis, either from the mean position, either upwards or downwards, is only 3 divisions. 1, 2, 3. Therefore, with 3 divisions being the amplitude, we just need the number of divisions times the Y gain setting. This is going to give us 300 volts as the peak voltage. Thank you so much for following. Subscribe and share.